All right, guys, today we're going to take a look at some relationships between functions and their derivative graphs and what everything means. We're going to go back over some of these properties. Okay, so good, that works. Okay, let's take a look. First of all, if f is increasing, then that means that f prime is positive. If f is decreasing, that means f prime is negative. If f has a critical point, that means f prime is equal to 0. We could also see this written as f prime, or f has a horizontal tangent. Okay, so just be aware of that same thing where derivative is equal to 0. F has a relative minimum when f prime changes from negative to positive. F has a relative maximum when f prime changes from positive to negative. And then I want to skip over some of these because I want to talk about concavity with the second derivative first. So if f is concave up, that means the second derivative is positive. If f is concave down, that means the second derivative is negative. And if f has a point of inflection, that means the second derivative changes signs. Doesn't matter which way, it can go from positive to negative or negative to positive, it just has to change signs. Now, let's talk about what this means for f prime. We just said if f is concave down, that means the second derivative is positive. Well, f prime and f double prime have the same relationship that f and f prime have. So if f is concave up and f double prime is positive, that means f prime is increasing. If f is concave down and f double prime is negative, that means f prime is decreasing. If f has a point of inflection, that means the second derivative is changing signs, which means the first derivative has relative extrema. So first derivative is changing from increasing to decreasing or decreasing to increasing. All right, let's take a look at what this may look like. We're going to start with a free response question. We're given the graph of the derivative of f. Notice that it says f prime out to the right. And we want to answer these questions. Notice that all of them say justify. So we want to justify using what's given. So all of our justifications should be in terms of f prime. So let's take a look at the first one. On which intervals is f increasing? Okay, well, if f is increasing, that means f prime is positive. So I'm going to go ahead and write that out. That's my justification. Okay, so we're looking for where f prime is positive. Okay, notice f prime is positive when x is less than negative 2. F prime is positive between 0 and 2. And when x is greater than 2. Now, notice we did not put those together in one interval because derivative is equal to 0 at 2, so that's not actually into the portion where we are increasing. Part B, find x-coordinates of any relative extrema for the graph of f and justify. So relative extrema, a relative max or min, occurs where f prime is changing sign. So I'm going to go ahead and write out my justification. Okay, f prime is changing signs. Part B, find the x-coordinates. So let's find them. Where do we have relative extrema? At x equals negative 2, we're changing from positive to negative, so that's a relative max. At x equals 0, we're changing from negative to positive, so that's a relative minimum. Notice that we're equal to 0. The derivative is equal to 0 at 2, but it's not changing signs, so that one is not a relative max or min. Part C, on which intervals is f concave down? Okay, well, f is concave down when f prime is decreasing. So again, I'm going to go ahead and write that out. So we're looking for where f prime is decreasing. Where is this graph decreasing? Anywhere where x is less than negative 1, we're decreasing. And then we are also decreasing between 1 and 2. Find the x-coordinates of any points of inflection. Okay, we said f has points of inflection when the second derivative is changing signs, which means the first derivative has relative extrema. So these are all the turning points. Okay, so relative extrema for f prime Let's go find them. At x equals -1, we're changing from decreasing to increasing. At x equals 1, we're changing from increasing to decreasing. And at x equals 2, we're changing from decreasing to increasing. So x equals -1, 1, and 2. Those are your relative extrema for f prime. All right. On which intervals is the graph of f concave up and has a positive slope? Okay, so let's talk about what that means for f prime. If f is concave up, that means f prime is increasing. And if f has a positive slope, well, f prime is the slope, so f prime has to be positive. Okay, let's go back up and take a look. Where is f prime increasing and positive? Okay, that happens between 0 and 1, we're increasing and positive, and from 2 onward. So we would say, what did we say, between 0 and 1, and when x is greater than 2, because that's where f prime is increasing and positive. Last one, find x coordinates of any points at which f prime has which f has a horizontal tangent. So that's where f prime is equal to 0. So I don't even need to move the graph or move the picture back up. Let's take a look. We're only looking along the x-axis. Where is f prime equal to 0? That happens at -2, 0, and 2. Okay, so those are the points where f has a horizontal tangent because derivative is equal to 0. Now notice you have some similarities in B and F, part B and part F, because your relative extrema occur at a place where the derivative is equal to 0, but is also changing signs. So notice that x equals 2 is a point where we have a horizontal tangent, but it's not a relative extrema, okay, because we're not changing direction around there. All right, now we're going to take a look at some multiple choice. Because again, we're starting to try to get ready for AP exam. We're still looking out in May for that. So we're going to try to look at some multiple choice here. Number 2, let f be the interval or function defined on the interval -3 to 5. Graph of derivative of f. So I'm going to make a quick note to myself, hey, this is f prime. Graph of derivative of f is shown to the right. Which of the following must be true? Okay, let's take these one at a time. Number 1, graph of f is increasing on the intervals -3 to 0 and 2 to 5. Well, if f is increasing, that means f prime has to be positive. So let's take a look. From -3 to 0, yes, we're positive. From 2 to 5, yes, we're positive. So 1 works. 2, instantaneous rate of change of f at 0 is 0. Okay, instantaneous rate of change is the slope, which is the derivative. So this is basically asking, is f prime of 0 equal to 0? So let's take a look. At 0, we have 0. Okay, so f prime of 0 is equal to 0. And last one, graph of f is concave up on the interval 2 to 5. If f is concave up, remember that means f prime is increasing. Take a look at this graph. From 2 to 5, we are decreasing. We are not increasing. So 3 is not true. So 1 and 2 are the only ones that are true. All right, let's take a look at another one. Number 3. Oops, I don't know what happened here. Why did that go away? Number 3, the graph of f prime is shown below. Which of the following statements is true? So again, this is f prime. I'm just going to make a little note to myself. Part A, f is discontinuous at x equals 3. Well, we notice at x equals 3, we do have a defined value for f prime, don't we? F prime cannot be continuous if f is not continuous. And notice that we have a value at 3. We are continuous there. We're approaching the same thing from left and right. So we know that f had to be continuous there as well. Part B, f is increasing on the interval 3 to 7. Okay, if f is increasing, that means that f prime has to be positive. So let's take a look. From 3 to 7, starting at 3, from 3 to 5, our graph is still of f prime is still negative. So that doesn't work. From 5 to 7 we are, but from 3 to 5 we are not. Part C, f has a relative maximum at 5. Let's see what's happening at 5. At 5, we are changing signs. In order to be a relative maximum, we'd be having to go from positive to negative. But we are changing from negative to positive, which happens with D. We can check E. F is constant on the interval. The slope is constant on the interval 0 to 3, but F is not. Okay. What this is saying is that the slope from 0 to 3 is -2 for all those values, but that's not a constant value. Okay. So if F was constant, then the slope would be 0. Your derivative would be 0. All right. Couple more. Number 4, the graph of this function on the interval -1 to 2 pi is shown in the figure to the right. How many critical values does F have on the interval 0 to 2 pi? Now, notice this one is a little bit tricky. We're only looking on the interval 0 to 2 pi, which is from here to the end, but they gave us from -1 to 2 pi. So always make sure you look at your interval because they can try to trick you with that. So let's take a look. How many critical values? Those are where F prime would be equal to 0, which means F would have horizontal tangents. Notice we would have a horizontal tangent here, here, and here on that interval. So 3. Number 5, graph of a twice differentiable function F is shown. So this is the graph of F. And twice differentiable just means first and second derivatives are continuous. Which of the following statements is true? All right, so we're taking a look. These basically have to do with the values of original function, F prime and F double prime at 5. This is the graph of F. So we can tell that F of 5 equals 0. F prime of 5, we're looking for increasing or decreasing. At 5, this function is decreasing, so we know first derivative should be negative. We don't know the value, but it should be negative. Let's think about second derivative. We're usually looking at concavity. At 5, this function is concave up. So second derivative at 5 should be positive. We don't know the value, but we know it's positive. Based on this information, we can list these in order. They're going from least to greatest. So we would start with F prime, and then F double prime, which matches up with C. All right. And then our last question, we have the graph of a derivative of F. So this is the graph of F prime again. Is shown to the right. Which of the following statements must be true? Number 1, F has a maximum at x equals C. Okay, at C, our derivative should be changing from positive to negative if C is going to be a maximum for F, which is not happening. Okay, it's not changing. It's not equal to 0 and changing. F has a maximum at x equals D. Take a look at D. At D, we are equal to 0, and we are changing from positive to negative for F prime, so that means F has a maximum at D. Last one, F is decreasing at x equals E. Well, that would mean that the derivative would have to be negative. Take a look at E. The derivative is negative at that value, so 2 and 3 are true. That would be answer choice E, 2 and 3 only. Okay, oops, I was hiding the others. So hopefully this has been a good overview of your relationships between graphs of derivatives and your other functions. We are going to do a lot of practice with this, but hopefully this was a good refresher for you guys.